Hey, welcome to the Electron X Lab. In this video, I'm just going to do a bunch of problems related to power in electrical circuits. So let's get started. First problem, what is the power dissipated by that 100 ohm resistor? This question is very straightforward. Power is equal to V squared over R. That's the equation we're going to use here. V squared is 144, the resistance is 100. .44 watts. Next question. Again, what is the power dissipated by this resistor? This time we have 5 amps going through it, and it's a 10 ohm resistor. In this case, we use the I squared R formula because the two things that we know here are the current and the resistance. And we get 25 times 10, 250 watts. In this question, we want to know what is the absolute minimum current rating for this fuse that we'll need for this system. We have a 6 kilowatt heater, let's say, driven from 400 volts. So basically what we need to figure out is how much current will be drawn by that circuit. Remember, power is equal to voltage times current. We know the voltage, we know the power. The thing that we don't know is current. Current is power over voltage. So this will be 6,000 watts over 400 volts. It's 15 amps. So when this is running, we can expect 15 amps through here. So the absolute minimum rating on that fuse should be 15 amps, probably a little bit more just to make sure it doesn't blow under normal operation. Now in this question, we want to know what resistor value will we need for this 1,000 watt heater if it's connected to a 120 volt source. So the heater is simply a resistor. It's connected to 120 volts. What is the value of that resistor that we need? Well, we know that power is voltage squared over resistance. We know the voltage and we know the power. So let's rearrange that equation for resistance. And we get resistance is voltage squared over power. So this will be 120 squared over 1,000 watts. And that works out to 14.4 ohms. So we'll need a 14.4 ohm resistor there to give us the 1,000 watt heater. Okay, in this question, we have a voltage source connected to a 330 ohm resistor. That resistor has a 2 watt rating. So the question is, what is the maximum voltage that I can apply to this 330 ohm resistor without exceeding its power rating? Again, we know power is equal to V squared over R. The thing we don't know is what is that voltage. So rearranging this equation, we get V squared equals power times resistance. So the voltage is the square root of power times resistance. And so in this case, it's going to be the square root of 2 watts times 330 ohms. And that's 25.69 volts, which is the maximum voltage we can have at this source before we exceed the power rating of that resistor. A really similar question here. We have a 220 ohm resistor with a 10 watt power rating. What is the maximum current that we can have going through this resistor before it exceeds its power rating? Well, since we've got current and resistance here for our power, we can use the I squared R equation. I is the thing that we don't know. So with a little bit of algebra to rearrange the equation here, we get I squared R. I squared is equal to P over R. And therefore the current I is going to be equal to the square root of P over R. Plug some numbers in here. 10 over 220. So the maximum current that we can have through that 220 ohm resistor is 0.213 amps. Okay, in this circuit we have an 18 volt source which is outputting 18 watts of power to R1 and R2, which are in series with each other. R1 and R2 are equal to each other, and what we want to find out is what is the value of R1 and R2. Well, here we have, we know voltage, we know power, we want to know resistance. So the equation, the power equation we're going to use is power is V squared over R. R is the thing that we don't know. We'll say that R is equal to R1 plus R2. And since R1 and R2 are equal to each other, it's just equal to 2R1 or 2R2. So rearranging the equation, we get resistance is equal to V squared over P. The voltage is 18. We've got 18 squared voltage over 18 watts. And that's going to work out to 18 ohms. So R is 18 ohms, and that's the total resistance of R1 plus R2. So that R is 18. So 2R1 is equal to 18, which means that R1 is 9 ohms. Also, since they're equal to each other, R2 is 9 ohms. Okay, this question, we want to figure out what is the output power from that voltage source. We know the values of the 3 resistors. We know the voltage across resistor 1, so now we need to figure out what power is being output by that source. And we know that the power output by that source is going to be equal to the power that's consumed by R1 plus R2 plus R3. So multiple different ways to go about solving this one. What I'm going to do is figure out what the current through R1 is first, and then that will also tell me the current through R2 and R3, and then I can use that current and those resistor values to figure out what is the power dissipated by each one of those resistors. So current through R1 is 9 volts over 1,000 ohms. So 0.009 amps or 9 milliamps. And that's the same as current through R2 and the current through R3. The power then dissipated by R1, well, we know its resistance value and we know its current, so we can use the I squared R formula here. Power through R2, also that should be squared there. Also I squared R, so 0.009 squared times 900 this time. And that works out to 0.0729 watts. And the power dissipated by R3, also I squared R, so that 9 milliamps or 0.009 amps times 1200 ohms. And that one works out to 0.0972 watts. And the power out is going to be equal to the sum of those 3 powers. So add those 3 numbers up, and I get 0.2511 watts. I can also use this information to figure out what the actual output power is. Again, a number of ways I could do this. I could take that current times the total resistance to give me the voltage, or I can take that current and the power and figure out the voltage. And so that's the way I'm going to do it. So I know that P equals VI. V is the thing that I don't know, over my current that I calculated over there, 0.009 amps, 27.9 volts. To double check my work, I can take the voltage V equals IR, and my current is 0.009. And the total, and the resistance will be 1K plus 900 plus 1.2K, so that gives me 3.1K, or 3100. What do you know? Exactly the same, 27.9 volts. So in this question, I have a 24 volt source and a 100 ohm and a 220 ohm resistor in parallel with that source. R1 and R2 are 5% resistors, so they can vary by plus or minus 5% around their nominal values. And my question here is, what is the maximum power output I can expect from that voltage source? So to approach this question, I need to consider the tolerance of these resistors. So the resistor for R1, the range for R1 is going to be between 95 and 105 ohms. And R2 is going to vary between 231 ohms and 209 ohms. So R2 is from 209 to 231 ohms. So the question is, will I have higher power output from this voltage source if both of these are at the high end of their resistance or at the low end of their resistance? Well, I know voltage and I know resistance, and so I can use the P equals V squared over R equation. Power is going to be bigger when resistance is smaller. So that's going to be at those 2 points. So the total power will be the power for R1 and the power for R2. So it's going to be that V squared over R1 minimum plus that voltage squared over R2 minimum. So this will be 24 squared over 95 and 24 squared over 209. And that works out to 8.82 watts as the max. So I think that about covers it for this video on power and some problems related to power. And I tried to come up with a number of different problems that are related to power and approaching power in electrical circuits in a number of different ways. So I hope that helps you with your understanding of power in electrical circuits, and you can take what you've learned here and go apply it to your own problem sets. Thank you very much for watching, and I will see you next time.